Hello and welcome to our webinar here today with Zend and InfoBright. The topic today is Big Data and the LAMP Stack, how to boost performance. This is actually based off of some research that InfoBright has done on doing analytics and such in a PHP environment. And so there's some interesting numbers I think that you're going to see a little bit later on. But before we actually get into that, I would like to cover some of the ground rules, or some of the basics, I guess, of doing a webinar here. If you do have any questions, we would love to have questions. But if you do have a question, please put it into the Q&A panel on the part of your WebEx Center there. You'll see it with the next little question mark there. Individual questions can go in there, and then that way we have a means of being able to check off the individual questions that have been answered and such. If you want to, say thanks or have, some run-on information, some additional information that you want to put in there, you can put that into the chat, just because it makes it a little bit easier for us to deal with that kind of communication going back and forth. Simply because it doesn't require us to then, say that we've actually answered a question when somebody's saying thanks. So if you want to say thanks, we appreciate it. But ask you to put things like that into the chat and put questions into the Q&A panel so that we can properly address those. Another thing to note is that we are recording this webinar. This webinar will be made available on Zend.com as soon as the the recording is made available. I will post a link to this on our Facebook page. And I'm pretty sure that InfoBright will be providing their links to it as well, so you can download it and watch it at your leisure at some point in the future as well. Just simply because there's a lot of information here, and it's really good to sometimes go over this stuff more often, just so you can kind of capture some of the things that are going on here. My counterpart here, if I am C-3PO, he'll be R2-D2. He's the one who actually did a lot of this testing and worked with the InfoBright engineers on working with this. His name is Jeff Kibler. He is the InfoBright Community Manager. My name is Kevin Schreier. I'm the Technology Evangelist for Zend Technologies. And with that, I would like to pass it over to Jeff, and he can start taking you through some of the data points of what we're going to be looking at here today. So Jeff, take it away.
Wonderful. Thank you, Kevin. Hello, everyone. Again, my name is Jeff Kibler. Today we're going to be talking about four main aspects, or four key items. First is the machine-generated data problem. We'll then jump into the benchmark in which we've compared InfoBright with Zend versus a MySQL/standard PHP approach. We'll talk about how InfoBright does its magic as well as what Zend really does to really drive performance under the hood. First, let's talk about the machine-generated data problem. A lot of us in many different industries, whether you're in a telco industry, a weblog industry, financial trade, you deal a lot with sensors or SIEM, you're dealing with the large data growth problem where all of a sudden all of our instruments are logging everything. Every computer is logging everything, and you don't know what to do with the data set. It's becoming too massive to find that needle in a haystack business intelligence report that you need to pull out of that. It becomes too cumbersome and very time-consuming. Takes a lot of effort in order to get that BI solution because of this machine-generated data problem, where everything is growing in leaps and bounds on the machine-generated data side. There are a few bloggers and technology enthusiasts out there that have differing opinions on what all encompasses machine-generated data, but all of them have underlined the reason or the core of machine-generated data to be anything that is created by a process in which a machine has logged an entry or provided some data to correspond to that process. What that typically means is that data grows very quickly, and the data very rarely ever gets updated, if at all. That's in contrast to the human-generated data aspect, which are more of your transactional side. It's more of your inventory, your things that are logged by a person rather than a computer on an automated fashion. When companies in these high data growth areas or low data growth areas come to this problem and they reach the point where they need to address the performance issue, when they hit that wall, the first reaction and the knee-jerk reaction is to throw money at it. You take your money and you tune and upgrade the existing database. Maybe you throw a few more keys on a particular database, you throw a little bit more indexing on a database, you upgrade the hardware, you change the processor, maybe you throw gobs of money at a new type of solution. Or perhaps you start archiving data. What you're really doing in that aspect is you're kind of avoiding the central issue of how do I adequately churn through this data set? How do I get through it the most efficient way possible? So that really begs the question. When you're performing an analytic, or when you're creating an analytic, you're not so much worried about the transactional side, because that's easily covered by MySQL, but what if you have to perform an analytic, where you're trying to dig and find business intelligence information out of the data set once you've hit that wall? Now try to do that without any database tuning and much less hardware. To kind of answer that question, we performed a benchmark that went through the difference between an analytic database, such as InfoBright, and a very good transactional database, such as MySQL, and just compared the two together, because they're designed for two different purposes. To give you an idea of what we evaluated, we really focused on loading time, compression, how easy it was to monitor and understand what was happening under the hood, as well as finally the results of the query executions, because ultimately that's the final verdict of the day. How long does it take your CTO to get a particular report? How long does it take your DBA to tune a database, if ever? And we did this using the InfoBright database along with Zen Server, and just compared it to the standard MySQL PHP stack. To give you an idea of what we were dealing with in our benchmark test, we used CentOS 64-bit, and we used MySQL and PHP, that latest and greatest up to date, along with InfoBright and Zen Server. We talked a little bit earlier about machine-generated data, and one of the data sets that's publicly available that is sensor data is generated by the U.S. government with the National Climatic Data Center. They provide sensor data for all daily weather reports from 1929 to 2011. This is publicly available. You can go and download it. It is the world's largest archive of climate-related data. So you can go freely try it out yourself. First, let's look at load time and compression. You'll notice that InfoBright raw data size is much larger than MySQL. The reasoning is InfoBright uses a different approach to how the data set should be structured. Instead of using a star schema like MySQL, we preach that things should be denormalized. Put everything together. One flat table is better than having everything spread apart. Both were optimized to the best way to approach the data set from a BI solution perspective. In MySQL, we indexed appropriately. In InfoBright, we condensed everything into one big database, one big table, actually, which is why the raw size, because we had to combine everything, is larger in InfoBright. But because of the compression that InfoBright was able to achieve, the actual database size was significantly smaller. And even the raw size used here, it's between 10 and 20 gigabytes, depending on which database you're looking at. It's still fairly small with how large InfoBright can go. Secondly, monitoring. Monitoring was a key aspect to our performance test. We had a person brand new to Zend, has been a PHP developer in the past, brand new to Zend, run and execute the entire benchmark for us. We wanted her to get a good glimpse of what a new user to Zend or a new user to InfoBright would run into. So we asked her to use Zen Server and found it amazingly good at being able to diagnose problems not only with the PHP code itself, but also with the query performance because of the monitoring capabilities of Zen Server with the query execution warnings, with the access log issues, and code tracing. And in fact, Alba is her name, who ran this, found it to be extremely easy to use and to configure. It allowed for easy debugging and monitoring of some very tough queries that we threw at the database. And we'll talk about the queries in just a second. And here they are. To get an understanding of the baseline queries that we used 9 non-analytic simplistic queries, where we assumed that it may be a toss-up between who wins in these particular baseline queries. They're non-analytic. They're just doing select counts, doing select distincts on particular tables, not filtering very much, if at all. So it's really just a straight pull from the database. Then we looked at queries of an analytic nature. things that we knew that InfoBright would probably have a leg up because InfoBright is designed for analytics. For example, simple number 1 listed on this report is reports descending list of snow depths from all stations around the world who reported a snow depth amount on a given date. So all you're doing is you're listing out your highest snow depth totals around the world for a given date. Whereas if you go to more complex examples, like complex number 2, for every station country that exists, give me the precipitation total and the precipitation report for all reports within a given date where the country begins with United. And so there's 3 countries in the world that begin with United. So in this report, it not only does string filtering, but it also gives you the most precipitation total and whatnot. And the actual queries themselves will be available afterwards in order for you to review and take a look. So how did we do? Well, off the bat, you'll notice that in baselines 1, 3, 4, and 5, InfoBright and Zend either performed at or below MySQL's level. That's directly related to the fact that InfoBright, the way it was designed, and the way the query was structured, because of the fact we do not use dimension tables, we use only one large fact table, MySQL was able to quickly pull out that information because of the database size, or the table size that was extracted from. For the actual executions of our analytics side, InfoBright shined much better with Zend than the standard MySQL PHP. MySQL is perfect for transaction side, and that's what they're really designed to do, is be a perfect transactional database because of the row-oriented technology. And we'll talk about the differences between row and column in just a second. And InfoBright is more designed for that analytics side. So what does this benchmark show? It really shows that with InfoBright and Zend, in the LAMP stack or in any combination, are a great pair for not only performance but also monitoring, because it allows us to expedite our development capabilities. It helps us monitor LAMP performance, gives us very strong compression with our data set, very fast data loads, and superior analytic query performance. All of this is the direct result of this benchmark. So let's talk about how InfoBright approaches its database and why it's geared more towards the analytics side. Firstly, we pride ourselves on doing things with much less work and lower cost. In InfoBright, there is no concept of indexing whatsoever. So any sort of self-tuning or managing the database by yourself is not needed because it's automatic. There's no projections, no cubes, no partitioning whatsoever. We do have that strong compression as shown by the benchmark. Very low cost because we do have an open source offering as well. And it's very fast to download and install. It takes a matter of a minute or two. Really the length of time is how long it takes you to download it. From there, it's just a simple MySQL standard installation. Let's talk about column versus row orientation. InfoBright is a column-based storage versus somebody like MySQL that is a row-based storage. Row is really good if you really need all the columns. So if you are doing a lot of transactions, if you're updating inventory, if you're updating an address for a particular client, especially where everything can be pivoted around one key element like an ID number or social security number. If you need to pull everything, row-oriented is perfect because that row is stored entirely in one slot on disk. So it's very continuous. When you pull one, you pull it all. So you pull one column of a particular entity in a row-oriented database, you pull them all. Versus a column-based storage. Instead of storing all the entities by row, we store everything by column. This allows us to eliminate a lot of the I.O. required, the reading of data from disk, based upon how many columns you pull. So for example, if you have 100 columns in a database, yet in your ad hoc analytic query you only use 3 of them, you automatically remove 97% of the I.O. required because you're not even looking at those columns anymore. Versus a row-oriented approach where you'd have to pull them all. Now if you're doing something like a select star on a 100-column database, then that's more of a row-oriented approach may be better because you're pulling everything from the database as opposed to just specific columns, like an analytic would do. In addition, we store everything via a data pack. What that really means is that for every grouping of data in a column, we combine it and we compress it. Because we're able to isolate everything by its type, since every column has its own set of data packs, we're able to compress it even more, such as strings. We're able to compress based upon the fact that it's a string, if it's an integer, based upon the fact that it's an integer. Typically, we see a 10-to-1 compression ratio. Some customers see as high as 40-to-1. So if you had 1 terabyte of raw data, compressed 10-to-1, it would be 100 gigabytes of disk capacity. In our example, in the benchmark, we saw about 20-to-1. So how do we do it from there? What do we do with that data set that makes it fast? Besides the fact that we remove a lot of I/O, a lot of reads from disk, we create metadata about each data pack. This is done automatically upon loading of the data. We store this information in what's called the knowledge grid. And the knowledge grid is loaded into memory from that point. So when you do your query execution, you're pulling straight from memory at first. What the engine does is uses that metadata to understand what's in each data pack to help further eliminate I/O, to help further eliminate the need to read from disk. For example, if your query says pull every column for anyone over the age of 25, if the column name is age, and for a particular data pack, all of the ages are below the age of 25, it doesn't need to pull out data from that data pack anymore because it knows it does not fulfill that query. Because of this approach, we can eliminate the need to partition data and eliminate the need for indexes. In fact, you can't even create indexes whatsoever in InfoBright. Ultimately, what it provides you is ad hoc queries become as fast as static ones. So you have total flexibility, your CTO has total flexibility, the DBA has total flexibility in what queries are executed, and the performance is static. Diving deeper into the knowledge grid, as I mentioned, there is a different set of information that is pulled depending on the type of data in the particular column. There is a concept of global knowledge, like for every data pack, how many nulls are in this data pack, or what's the minimum value, what's the maximum value. And depending on the type, it'll further break down depending on if it's a string, if it's a number, if it needs to pull distributions. And finally, you may ask, well, what about if this is created on load, it's loading into a table, what if I'm joining two tables together? We do have a concept of a dynamic knowledge node, which is generated when the join occurs, and it's kept in memory for use in future queries. And to kind of summarize how the engine works, if the query you're doing or how are my sales doing this year, the very first thing it does, it goes to the knowledge grid. It's quite possible that the knowledge grid has the answer already stored. If it doesn't, it iterates through the knowledge grid to understand what data packs need to be read, need to be decompressed and read and used in the computation. If data packs are needed to resolve that query, only those are decompressed and used. And finally, that gives you the result. To kind of give you some other performance statistics besides the benchmark that we had performed, all of these are with analytics. If you're trying to do it more for a transactional side, you'd be best to look at someone like MySQL. But for an analytics side, it's perfect just to take a look at these numbers to understand how long it takes to execute a query. So a query that took 2 hours to MySQL took less than 10 seconds from one of our customers. And as I've mentioned several times, MySQL is an amazing product that is very complementary to InfoBright. In fact, MySQL and Sun were one of the original funders for InfoBright when it first started because we use the MySQL architecture. What we've done is we've replaced the InnoDB engine with the Brighthouse engine, which is our internal engine, added in the knowledge nodes, the knowledge grid, as well as the loader. But we kept everything else the same. So all of your connectors, whether it's JDBC, ODBC, if you're using Python, Perl, Ruby, the connectors you use today through Zend or through any other technology works just like you were connecting to a MySQL database. We have many users who use MySQL and an instance of MySQL to do all their transactional side. And then every so often, whether that's every 5 minutes or every million records, we'll take all of the transactions and move them over or copy them over to the InfoBright database to be used within their analytics. To break down a little bit more about who uses us, you've got a lot of mobile analytics providers, cell phone providers, telecoms, call data records. We have quite a footprint in capital markets, understanding stock trends, as well as security with the SIEM market, as well as an OEM embedded offering that's also available. And with that, I'm going to transition it over to Kevin, so Kevin can talk a little bit more about the Zen side.
Well, thank you very much, Jeff. I think that this is really kind of an interesting thing that we're looking at here, because one of the things that we've noticed, well, it's not something that we've noticed, it's something that we're actually pretty much geared up to handle, is that there's a lot of interest in PHP on the enterprise side. A lot of the competing languages and competing infrastructures out there that they've been using for a while. There's a lot of costs involved, both hardware as well as on the personnel side. And we've actually seen a lot of enterprises actually move to PHP because they get things like faster development time, and they don't have the same kind of programmer costs, the same kind of administrative costs. And so we've seen a lot of enterprises actually taking PHP and running with it. I mean, at our ZenCon this past year, we had Matt Merchant, who's the CTO of GE Corporate, who was talking about how they were working with PHP in a very much, if you're not talking about if you're talking about a large enterprise, GE is a good example. We also had a gentleman from the New York Stock Exchange talk about how they had been working on a Java application for, I believe it was 2 years, and they just said, we can't be doing this for much longer. Let's take a look at some additional technologies out there, and they took a look at PHP, and they were able to bring up a solution in about 3 months. And so you have the enterprise type of organizations who are looking at PHP and seeing that there's a lot of benefit to moving their organizations to there. And that's, I think, really where you see a really great tie-in with InfoBright, because what we end up having is an organization, an enterprise-level organization, is going to be working with lots of data. And so the ability to do analytics on that type of data is something that's incredibly important to an enterprise. And so being able to get a report back, in what was the number, 12 minutes as opposed to 11 hours, if you're running on, if you're basically doing with MySQL or doing with other databases something that it's not really designed to do, it's a great thing. And being able to connect in directly with the stuff that you see in PHP, the MySQL drivers and things like that, makes it a very easy way to use PHP for your analytics. And so one of the things that we do is we try to provide a solution that helps enterprises and small businesses, various organizations, provide the kind of PHP support and additional functionality that they are going to need. And so we have a couple of different offerings that we provide to people. Some of these you might actually be familiar with. Zen Studio is an IDE that we have created. It's based off of Eclipse, which is actually really quite beneficial because it's based off of Eclipse, you can also take additional functionality that other Eclipse community members have built and quite easily integrate it with your IDE. For example, I'm obviously a PHP developer, and PHP is what I know, and Eclipse is a Java-based IDE, so you can build Java code in there as well. But the other day, I was just kind of messing around and wanted to download some C and C++ code, which I'm not as strong in. But all I've got to do is go to the community, download that plugin, and I'm all of a sudden able to write code in C or C++. Additionally, there's a whole bunch of other connectivity that you can do. There's a lot of source control mechanisms that if you're going to have an IDE-based source control mechanism, it will be in Eclipse. If you're going to have a task management system, there will be an Eclipse connector. And that's why we had chosen Eclipse to be the foundation of the IDE when we moved over several years ago already, that we moved over to the Eclipse ecosystem. And so that's so that you can get more of the stuff that you need in order to build your application. We also include in Zen Studio Zen Framework integration that understands some of the technology behind Zen Framework, and that makes it easier for you to manage manage the application that you need to work on. So if you're building any kind of custom analytics, it'll understand the structure of a Zen framework-based application so that you can go between various components much more easily and have a lot of the stuff automatically set up. And it also includes Zen server integration, which I'm actually going to take a look at some of the features that I think are more pertinent to you on the Zen server side in the next slide. But Zen server integration is one of the things that we present in there as well. On the PHP side, we have a couple of different pieces of functionality. I'll highlight just a couple of them before talking a little bit about monitoring in a bit. We do have our cloud services layer, so that if you're working on the cloud, we have a cloud agnostic setup, and I believe that InfoBright works fine, in the cloud. I mean, you can set up MySQL in the cloud, so you can set up InfoBright in the cloud. So if you want to connect into some of that cloud functionality, we have some integration points there that are actually part of the Zen framework that you can use for data access, message queuing, file access, things like that. You can access that using Zen framework when you're running in one of the supported cloud implementations. But also, too, on the Zen server side, we have a couple of additional features that actually help you work with an environment that is, I guess, more robust. In other words, one that if you're dealing with large amounts of data, that data has to come from somewhere. And so we have some of the functionality here to help you with that. First of all, with session clustering, if you're kind of taking the traditional pizza box approach where you have 10, 50, 100 servers that are there serving up your individual apps, this allows you to transparently send sessions back and forth between machines, giving you a great high availability solution that does not have a single point of failure. Application monitoring, I'll skip over that for the time being because we'll actually cover that more in the next slide. Cluster management, we have a product called Zen Server Cluster Manager, which I actually just used in a video that I posted on the Zen Facebook page that allows you to manage and aggregate data from multiple different nodes so that you can more easily gain insight into your application and more easily make sure that you have a consistent configuration across individual nodes. That goes in with configuration management and things like that. So the base solution that we have is really built for allowing an enterprise to get the most out of their PHP installation. Everything that if you write for Zen Server running on Zen Studio, there's nothing in the base language that we change. It's all the same thing that you would be able to get. We just add some additional stuff on top of that. And one of the things that we add on top of that is, again, application monitoring. So, Jeff, if you can forward it to the next slide. Application monitoring is really one of the cooler features that we have in Zen Server. And this is one of the things that I think is important if you're looking at big data. Because if you're dealing with big data, you could be dealing with lots of different data points where you could be inserting data. And also you're often going to be dealing with larger organizations or larger environments. If you're dealing with one or two servers, you might be able to get by with just using simple logging. But what monitoring does is it looks for about a dozen, depending on if you're using a cluster manager or if you're just using a standalone Zen server, between about a dozen and a half to 2 dozen individual events. So we see a couple of examples here, things like slow request execution, fatal PHP errors, slow function execution. So if you are trying to make a web service call to get some data and you're expecting it to come back in 3, 4, or 5 seconds, whatever it is, you can set thresholds for various events that allow you to know when there's actually something going on in your application. And knowing is something that's quite. It sounds simple to do. You say, okay, I'm going to be looking at logs. I'm going to be pinging the server every once in a while to find out. But actually knowing when something is going on is actually quite difficult to do. In an example that I did just a couple of weeks ago, there was an error going on in my system. I had about 20 servers set up. I was running on an EC2 instance. I was just kind of throwing load at these machines, and they weren't. There was an error in there, but all I knew was that I wasn't getting certain pieces of data back. And so what I did was I installed XenServer Cluster Manager so I could kind of get a cluster-wide view of what I was looking at. And about, I don't know, I guess about 5 minutes or so, I had figured out what the problem was, fixed it, and was on my way. If I was not using this combination of monitoring and the XenServer Cluster Manager, this would have been something that would have taken several hours just to know where the problem was occurring, let alone what that problem actually was. And so monitoring gives you that knowledge that something has occurred. It tells you what the context is, and it gives you a little bit more peace of mind knowing that you can actually know when you're having an issue. But knowing is really only half the battle. The other side of that is actually being able to debug and fix the issue. And that's where we have another feature that's tied in with monitoring called code tracing. Now what code tracing does is it stores the request execution flow from the first request coming in until the last shutdown hook has been executed. It will store the files that were included. It will store the individual function parameters that were passed, method parameters that were passed, return values, exceptions that were thrown, memory consumption being used, as well as storing the running time for each of these individual function calls. And this allows you to, in many cases, I'd probably say even about half the time, be able to go into an issue that you're seeing. If it's either a slow query, you're doing, there's some kind of data that you're actually, doing some kind of an analytic on. You're trying to, say you're trying to get sales for the last year, and you're thinking to yourself, well, I know this is a big table, but it really shouldn't be taking 20 minutes for this query to come back. And what you can do is you can actually take some of this, take a code trace of this, which occurs when an individual event is thrown. So say we see here, we see fatal PHP error here, or severe slow request execution. Those are the two errors that we see here. What we can do is we can tell XenServer that when one of these issues occurs, to then dump that code trace, dumps it onto the file system, and it contains all that information of the entire request flow. And then what you can do is you say, okay, well, I know I'm having this issue. You can go in, see if there's an event that was created, and if there was, you can go into that event and see a button that says Show Code Tracing. You click on that, and you'll be able to follow that execution flow. And in many cases, you don't even need to replicate the issue because you can often see what's actually causing the issue directly inside of in the code trace data that we see here. You can see a screenshot of what that actually looks like. And so what code tracing does, it just gives you a much greater insight into what's actually going on in your application, because not only are you getting not only are you knowing that something's occurring by using monitoring, you're actually seeing what's causing the thing that's occurring by using code trace. And so it gives you a complete solution to allow you to work with this information in a production environment, which I think is the key thing. In a debug environment, you can see this is incredibly useful, but it's extremely useful in a production environment that you know that in your production environment, A, that something is happening, and B, what do I need to do to either replicate or fix this issue? And so using those two together are really a great combination to actually have to reduce the amount of time you spend on issues and see what gets some actual insight into the application that you're actually running on. So that's kind of a combination there, and it works really, really well. Jeff, from there, what do we do to actually get started and kind of get some of this stuff kicked off?
Great question, Kevin. Ultimately, you can take a look at both technologies. You can go to Xen.com and take a look at XenServer and Xen Studios. They have both the enterprise side as well as the community editions available, as well as the recorded webinars, which actually proved pretty useful too for our person that was being introduced to Xen for the first time. So take a look at the recorded webinars and training sessions on how to set up XenServer and how to set up certain attributes of Xen. As for InfoBright, if you'd like to take a look at our community edition, visit infobright.org. We also have our forums in case you're interested and need to learn more about the technology or have a question when you're setting it up or getting it running, as well as infobright.com, which has our free trial of the Enterprise Edition, our white papers, links to our videos, and other bits of info. So feel free to take a look. If you have any questions for Kevin or me, please feel free to email us. It's kevin@zen.com, or you can email jeff@infobright.com or jeff.kibler@infobright.com. And we're also available on social media. You can follow us. We were live tweeting a little bit during the presentation, so feel free to take a look at our offerings. So I guess at this point what we'll do is we'll give everybody a minute to ask any questions and put them in the queue, and then after we give everybody a little bit of time, we'll start answering those questions.
All right, well, while we're waiting for people to put some questions into the Q&A, we actually have one there already. We'll give you a little bit of a chance to write any more. Could you talk a little bit about the actual installation process? You download InfoBright, you install it, and from the PHP side, pretty much what needs to be done, what things do we need to take into consideration there?
When you install InfoBright, it's a very good question, a very common question. You can use the same hooks that you use today, whether it's MySQLi or using Zen Framework to connect to the MySQL database. All you really have to change is the port number. Straight up, just the port number. Everything else works seamlessly as if you had it before. So if you used you have your page today, you've got your queries, you have your database set up, and you want to connect to it using Zend or using PHP, MySQLi, all you really need to do is change the port number from 3306 for MySQL and change that over to 5029, which is the port for InfoBright. The best thing is you can have an InfoBright instance and a MySQL instance running at the exact same time. So if you needed to have the MySQL side and the InfoBright side running it together, that's easily done. So in terms of how it works with Zend, if you're using Zend Server, it has a very easy-to-use console where you can just change the default port number right then and there to 5029, or change the socket that's used, depending on how you want to connect to the database. But it's quite simple, just straight up changing the port number or the socket.
That's pretty easy. That was one of the things when I first tried that. I mean, you pretty much install InfoBright, you change the port number, and at that point, it just works. It's really nice and simple. All right, so let's go through a couple of the questions here. We have one question: what tends to cause the sudden drops in performance with a little warming you allude to in the marketing email for this event?
Good question, and we hit on that a little bit. The big thing about MySQL and the difference between MySQL and InfoBright is the fact about indexing. As you're loading machine-generated data, and we talked about how fast it's growing, Gartner projects it to be 650% growth over the next 5 years. So we're talking staggering amounts of data, easily at minimum 50 to 100 gigabytes, if not up to 50 terabytes. It's that range. You start seeing degradation in performance because of the indexing aspect. MySQL, because it does have indexing, you almost need it for an analytics solution. You tend to grow your database, which is why you lose a little bit of the compression that exists with MySQL. So you're kind of getting a double whammy in that respect. So for a MySQL database in which you need almost near ad hoc query performance, where everything is about the same, you'd almost have to index every column. And if you do that, you're going to start really blowing up the size of the database. So a 1 gig database, if you have it indexed out the wazoo, is now 3 or 4 gigs. Your size just grows so big, and your indexing grows along with it. Load time starts to suffer. Performance on the query still can't keep up. So in the beginning, if you have a very low data amount, I'm talking less than a gig, up to even 5 or 10 gigs, you're not going to notice much difference. But once you get above that point, you start seeing a slow change and difference. And as you go up and up and up, you start seeing more and more performance separation between the two, because you're using it as an analytic. If you're using it as a transaction database, still MySQL is the way to go. But if you're using it for an analytics database, InfoBright's the more appropriate solution because of the fact that it's designed to handle that large data set, and it doesn't index, so your size stays relatively flat. It goes proportion to the size you're loading in, not more so. So that's why when we talked about in our marketing email, why the sudden drop in performance. You're loading so much data that over time, and even very quickly over time, we're talking a matter of a few days if your data size is large enough, your degradation performance is significant. And what ends up happening, as we talked about, is people start chopping the data off, or they have to fine-tune everything, or they have to do things to the data set itself as opposed to addressing the problem.
Right, that's one of the things. Prior to being the evangelist for Zend, I was actually working as a consultant, and I ran into several instances where people just had lots. It wasn't something that you think about, terabytes and terabytes of data. It was actually in the range of just a couple to maybe 10 gigabytes or so. But because of the type of indexing they needed to do and the types of queries that they were doing, these weren't things that could just simply be stored in RAM. You could add, another couple of gigs into RAM, and it really doesn't matter if you add more gigs into RAM if you have 10 people doing the same thing on, 100 million rows or whatever it is. And so what that ends up doing is you end up having to throw that data, onto the hard drive, or have the database throw that stuff onto the hard drive, and the hard drive is much slower than RAM. And as soon as you hit that template, it's kind of funny when you watch some of that type of testing. You can see the performance is going up. You're getting more throughput. You're getting more throughput. All of a sudden, you kind of see the graph kind of level off, and then it just tanks because there's just so much going on that the operating system and the hardware just cannot handle it. And you can see that pretty significantly sometimes when you're doing those kinds of queries. Next question here, is InfoBright 100% SQL compatible with MySQL?
So we do, yeah. The answer to that question is yes. We do have a SQL standard that we use. There are some bits of syntax that are not supported yet in InfoBright, but all of the syntax that we do have is the same syntax that you would find within MySQL. And in terms of working with MySQL, we actually still keep the MyISAM engine. So if you needed to use MyISAM for whatever reason within InfoBright, you can still use the MyISAM engine to get the same performance. So if you had a query that required some sort of syntax and didn't necessarily need the columnar data store that the Brighthouse engine provides, you could still go ahead and use the MyISAM engine. If that doesn't completely answer the question, just let me know.
And the next question is how easy it to import your data into an InfoBright database?
Great question. It's actually quite easy. Ultimately, no matter what database you're moving from and moving it to, you still have to extract out of the old and import into the new. To import into the new, we do have a bulk loader option that is extremely fast. It's the extraction out of the host database to start with that may or may not be the bottleneck. But ultimately, it's fairly straightforward. There are a whole host of tools that have been used. We've created our own that are available within our .org site and under our contributed software page, where it helps you move from, let's say, MyISAM or InnoDB. Maybe you've got a separate instance of MySQL running and you want to move from InnoDB over to InfoBright's instance. There are tools already available to help you move. There are also some industry-wide ETL-type tools that may help you, that may make it a little bit easier for you, such as if you wanted to use like Talend or Jaspersoft, even though they use Talend. But there are other tools that help you with the ETL side. They can help you move stuff over from one database to the other.
Next question is here. What is the difference between ICE and the IEE version?
Another good question. Very similar to Zend. There are definitely some performance differences. Actually, I'm not sure. I won't speak entirely to Zend's side, but there are just some differences in functionality that exist within the EE side, in addition to indemnification, as well as support levels, as well as other business-oriented differences. Plus, with respect to features and functionality, multi-core support is available in IEE, but not in ICE. In addition, DML is available in IEE, but not in ICE, as well as some other functionality, some cool new functionality that's coming out, that's been out, is dynamic load processing. And in the future, there's some really cool stuff that's going to be available only for IEE, but it's not been released just yet. But we're further building onto our ICE packaging, but also our IEEE, there's a differentiation that is, of course, there. If you wanted to take a look at a matrix that's available of what's available in ICE and what's available in IEEE, take a look at infobright.org, and on there there's a big button that says, what's the difference between ICE and IEEE? It can tell you all of the big differences between the two.
Cool. Next question is here: Is InfoBright is, or let me start over. Is InfoBright a database like InterSystems Cache?
To be honest, I don't know much about InterSystems Cache. I'd have to do a little bit more research to give a more intelligent answer. But InfoBright is similar to other database types out there. It is a columnar data store. We are the only one, though, that uses the knowledge grid, which is that metadata surrounding it to kind of help speed up query execution. There have been some comparisons between InfoBright and other columnar data stores as well as non-columnar data stores. As I mentioned, MySQL, a row-oriented database, is perfect for transactions. InfoBright column-oriented database is perfect for analytics. Then you've got all the NoSQL variants, like Cassandra and Hadoop and all of the fun new technologies that are coming out. They all have their spot that they really fill a great need. You really wouldn't want to move one to the other. In fact, they're very complementary, all of these different technologies. What you'll want to do is, if you want to take a look at the different types of technologies, take a look at their family of technologies. So look at all the row-oriented together, like MySQL. Look at all the columns-oriented, put them together like InfoBright. And then the NoSQL variants can actually be split up into 3 more factions from there. But my point is really, even though I don't really know InterSystems Cache, I would like to learn a little bit more, and perhaps I'll get back to you individually on this one. But take a look at some independent studies that were done by the MySQL Performance blog. Percona is the name for the MySQL Performance blog, and they will give you some comparisons between the different database types.
Yeah, if I remember correctly, Cache is basically an object database. They call themselves a post-relational database. I actually looked at them back in 1999, I think. But I think it's actually a different type of a setup where what they're trying to do, and I might be stating this a little bit incorrectly, but what they're trying to do is they're trying to map the database directly onto your object structure as opposed to doing queries. And I think that's actually kind of a different type of database family than what we're talking about. You have your standard MySQL, which is good for your transactional queries. You have something like Cache, which is an object-based database, so it basically understands its data as objects. And then you have the analytics side, which is what InfoBright is doing. So I think that it's more, I think it's actually within a different type of database family.
Okay, so is it more of a SaaS type of model, or is it just that object-oriented side, or object side, and that's how they kind of play?
I haven't looked at it in a while. I'd have to dig a little bit more deeper to see how it's actually done. But they really seem to have a foothold in the healthcare market and within Java-based applications because of that strict or that tight coupling with the object model.
Okay.
Next question is, can we use PDO MySQL extension to connect with InfoBright?
Great question, and I'm actually researching. I want to make sure that I'm giving you the full answer to that question. As long as you can connect to MySQL database, it's the same connection type, so it theoretically should work out of the box. I did not test that specifically just to make sure that, especially when you're using the Zenside or straight up PHP, but I can contact you directly. But ultimately, if you can connect to a MySQL database, you should be able to connect to us because we use the same native connectors. It's the same connection type. The only difference truly is the engine underneath. That's the core difference. So it's kind of like you can change the engine of your car, but really the outside is stay the same. You still get into the car the same way. It just drives different because you have a different engine. So while I've not run across someone who's used PDO specifically, that's something I can address with you offline.
I think that you actually have, because I think that's the way I have. That's the way I did.
There you go. Ultimately, at the end of the day, the best part is that with Zend and InfoBright, you can connect seamlessly because of the fact that Zend has everything together. I love Zend Framework, by the way, and connecting to InfoBright. It made it extremely easy. So with InfoBright, if you can connect to MySQL, you can connect to InfoBright, and that's basically the underlying statement.
All right, the next question we have here, how does InfoBright performance scale with data size and concurrency? I think that you already talked with about data size, and so I think the concurrency would be, I guess, the bigger part of the question there.
Okay. So in terms of scaling, of course, we do scale with size and concurrency. You really get more bang for your buck out of both if you do go more towards the enterprise side. The Community Edition does do fairly well, especially versus other types of analytic solutions, but ultimately you're going to get more bang for your buck if you go to the enterprise side, especially if you need a lot of concurrency. A lot of maybe you're doing a bunch of loading on the data and then trying to extract it at the same time, and maybe you have a bunch of users. It really all depends on what your level is, and I think in your situation, feel free and reach out to me afterwards, and we'll talk a little bit more about the specific need that you have. Ultimately, we do say about size. I mean, you can go up to the multi-terabytes and not have a problem. We have one particular customer that loads on 1 terabyte of data a day. Then they roll off 1 terabyte every so often just to kind of keep it at a size within, under 50 terabytes is where they were targeting to keep the performance at the level that they wanted. But getting up to that level is pretty safe with us.
I guess another question that you could kind of tack on top of that is, read concurrency as opposed to write concurrency. Is there a difference there? Well, obviously there's a difference there, but are there places there that or things to note about that between? So
when you're loading data in, it does take a lot of power, especially if you're using ICE, because we are single core at that point. It's a single core process where you're reading and writing, so you really can only do one operation at a time, especially when you're doing a massive bulk load, which is why a lot of our bigger users, eventually what they'll use is InfoBright's ICE Community Edition for some aspects of their data warehousing, but then maybe use the Enterprise Edition to do a lot of the concurrency side with reading from data. Reading from data, it doesn't take as much resource intensive as something like writing to the data. That's actually a difference in functionality that's between IEE and ICE, is the fact that you can read while load in IEE, but not in ICE. So there is a difference there.
All right, I don't see any more questions there. So thank you all for joining us. Like I said earlier on, this is being recorded, and it will be up at the Zend.com website. We'll be posting that on our Zend Facebook page, and I'm sure that you'll be able to get that off of Twitter as well. I would like to thank Jeff for joining us here today and looking at how you can implement analytics on kind of on the MySQL side, and how you can integrate all that kind of stuff with Zend Server. It's a lot of interesting data points there, and I think that it's beneficial for those of us who need to do analytical type of data manipulation. So thank you all.
Yeah, thank you, Kevin, too. Zend was an absolutely wonderful company to work with, and I look forward to a good future between the two of us.
Well, thank you. And for all of our attendees, thank you for joining us here today again as well. We look forward to seeing you in another webinar at some time in the near future. So have yourselves a good day.